Welcome back, everyone. This is Frank Whiskey Charlie Zero Oscar. And what I want to do is I want to talk to you about my experiences in modifying the MX-P50M amplifier for the IC705. The information that I'm going to provide you was I received it from Kevin Loughin, who has a great channel on YouTube. And there's other resources available as well, schematics and also builds on this modification. You can buy this amplifier on Alibaba, eBay, Amazon, and it's believed that everybody gets the same. There's only one place that makes this, and apparently people will sell it to you. Prices range, but it's inexpensive. And the shipping cost is something that you should consider, because I think the shipping cost makes the amplifier a little more expensive. For example, on Amazon, you think, oh, I'm going to get it in 2 days or something. No, it's shipped from China, and it's about $200 compared to somebody like an eBay that might sell it to you for $127, but shipping is $30 or something. So you gotta just shop around. When you receive the amplifier, you'll receive a power cable, you'll receive a signaling line, and the plugs. I'm going to be using the 3.5 millimeter tip ring sleeve in this case. We'll talk a little bit about that. So Kevin explained that there's a small amount of current going through the signaling line, and the IC705 can't manage that. That's the gist. So we're trying to manage a small amount of current that goes through the signaling line. So he created a single transistor driver for the relays. So this is the schematic for the modification. So what's happening in this modification is that we have a PNP transistor, which is a 2N3906, that's able to handle at least 200 milliamps, which is great because the current that's getting from the relay is about 40 milliamps. And it's a PNP transistor, meaning that this has a current. No, if there's a voltage of 6/10 of a volt, then nothing will go through this transistor. There's also a reverse bias diode, and this one is the 1N914. And these numbers I got from Kevin. He was really nice enough to help me figure out which components to buy. And actually, the 2N3906, you'll find that he talks about that particular transistor. And then the resistor is a 10K ohm, where it's high like this so that it can give off a small, tiny amount of current. So the way this works is that when you when you press the PTT button and want to key the amplifier, the line will go into ground. And so when that happens, this voltage will go to 0, and then the current will go through the transistor and out. And when it does that, it's going to key these relays, energize them, do its magic, and then it's going to transmit your voice and amplify it. At that time, there's a small, tiny amount of current that goes to the radio, which it can manage. And we'll talk about which wire goes where in a minute. Now, when the relays are not in use anymore, there might be a small, tiny amount of current, a spike of current, that might damage the transistor or the radio if this transistor was here. So there is a reverse bias diode. So instead of going through the resistor and maybe getting it, the transistor and getting it damaged, the current will go through the reverse diode and then dissipate normally. So this diode protects the transistor and the radio, and that's why he has it there. If you want the best explanation, you got to watch Kevin's video, and I'll provide it down there. It's great to listen to him. So that's the layman's explanation, or this is the way I kind of like learned it. But this is really neat. This design is really nice. So let's look at what I did and how I put it together. So you have the PNP, right? PNP has a flat side to it. And the PNP has 3 leads. It's an emitter, base, and collector. And the emitter here and the collector here, you can see that the diode is connected to these 2 leads. And the diode is pointing a certain way. It does have a certain direction. And from there, you have the base, which is connected to the resistor. Now, let's talk about the leads that are going out. On the emitter side over here, that's connected to the diode, there is a line, there is a red line, positive red line, that goes to the amp. And that line you'll see down here in the modification when you start cutting into the wire there. And then also on the collector side, you'll have a black wire for the signaling line, and that's going to go back to the radio and to the amplifier. So you're tapping into that wire. So that's going to be the ground side. And then the base after the resistor is going to be the 13 volts that you're going to get from the amplifier, which is this blue wire here that's tapped into it. And then on the other side over here, you'll have the positive side, and that wire is going to go to the radio. So there's a red wire that you're going to cut in the into the amplifier. When you cut that red wire, one part of that wire that's going to the amplifier, that's going to connect these components, and then the other side of that wire that goes to the radio, you'll hook it up here. Now these components, they come in a variety of ways. Usually you get more than one. So in this case, the transistor, I get 20 pieces, and they're all nice and packaged. The 10K resistors, I had 10 of them. I only have 2 left. And the reason is I built another modification on one of these. So I spent like 2 or 3. And then redoing this, I spent more for testing. I'll tell you a little bit about that. And then the transistors, you'll see that the transistors have a tiny black mark. That black mark will tell you the direction at which you're supposed to solder it. So the cool thing about these, they're not that expensive. You can probably get them. I'll give you the links of where I got them, but you can buy them in probably an electronics store that sells components like that. Now the reason why I don't have many resistors is because I was doing different my soldering skills are not that great. Uh, my soldering skills are not that great, and then putting the components in a particular order is something that you're just going to have to figure out. What I did was I put the resistor in the front. And this one doesn't give you that here, this one. And you can barely see it. Here you go. As you can see, I put the resistor in the front of the flat side, and then I have my diode on the back. And the reason why I did that was because I will flip it over. And when I flip it over, I'm able to have access to the resistor that I'm going to tap into the power source on the back side. You're gonna, my design might not be the best, but I figured out that that seems to be something that is reasonable. You'll find also that the proto boards, I had a nice little proto board and I just cut it. And I use some pliers, or you can etch it and then snap it. Some proto boards are cool, some of them are not that cool. Like, let me see, I don't think I have a proto board here. Yeah, like this proto board here, the only thing I don't like, and that because I'm not that great in soldering, is that, and let me put this here, is that, I thought, oh, this is cool. It has the copper strip here, and if I solder one, I can solder the other one, and I don't have to connect one with the other. But the thing is, when I soldered one, it kind of leaked, and it spread out more to the other end. So I didn't know exactly how to manage that. So what I did was let's see, here's a bigger version of that. See, and it's cool. Like, oh, you can use these paths, and you don't have to bridge the solder. But again, I wasn't doing great. So I used this one instead. Where, here, let me move this guy. Where there's just single copper rings. And then I was able to manage to put like a little bridge between the two connections. The way to do this is you solder one point, you solder the other, let it cool down, and then take a little solder and then bridge it together. And that's the trick. Don't solder one, solder the other, and try to see if you can bridge both. It doesn't usually work that way. But then again, if you're a pro, you probably could do it. So you might expect that you might create, different prototypes, or even practice on your soldering, because sometimes the soldering is horrible. Getting the right tip and the temperature, and if you haven't practiced, it's a pain in the behind. So that was one issue, getting the correct orientation on the components. Now, over here on the keying wire, or the signaling line, right? That one was pretty interesting to do, because it, you get a pack of the plugs, but I didn't like that. I like the right angle version. So I went to my local swap meet, and you could rummage around, and I finally found a right angle. You can buy them too on eBay or in Amazon, and I did buy one in Amazon. A little bit pricey, but it's too small. But still useful for another project. Or you can buy maybe quote unquote better plugs that are easier to connect. But none of them, this one wasn't a right angle. So that could be for another project. Right angle, why? Because when you put it into the radio, it doesn't extend out. And sometimes when you plug things on the radio that's extended, the wire will mess up the plug on the radio. This one is a little bit harder to mess around with. These, I don't know, have you noticed that these cables, they don't give it to you for $1. They'll say it's $3. And then if you want to buy another one, 2 for $5. That's annoying. But hey, good deal, $3. So in this case, we have the tip, the ring, and the sleeve. Now the tip is going to be positive. It has to be positive. And the sleeve will have to be negative. And this is what you need to do to connect it to the IC705. So what you're going to have to do is, in my case, was I cut the wire, and then I used a digital multimeter to find the signal. The multimeter is cool, actually, in terms of trying to find if the connections are good or not, especially when you do the your prototypes. You want to make sure, hey, is the signal going from one component to the other, and that's a neat thing, having a multimeter that can do that and tracing your signals. Okay, the other thing too with these, if you're going to use these type of this method of getting another wire, instead of using these, right, and using the cable that are provided for you, the lines are really tiny, so you got to be very patient, and you need to strip out the wires and the shielding and fold it back, and then you have to also make sure you tint the lines, and you should put tubing, right? The shrink tubing is important for doing these type of operations. It's really nice to have a box of different sizes of tubing, because for this connection, I think I put 3 shrinking tubes, to give it that strength that I need, because the wire is really tiny, and if that snaps, then it's not going to work very well. So you got to take your time for that. As for the power, I decided to not use their connection, right? I don't like their connection, but I do like it that they give you a fuse box. So at this section, I cut the connection. I just put the wire they provided me, did a nice little solder there, put the shrink tube. I've done that many times. This will hold very nicely. And then on the other end, I don't want to use their plug. I'm going to use, or any other type of plug. I like to use Anderson power poles, so that I can connect to my bioanode battery. This one is 3.5 amp. This will power the amplifier. 3.5 amp hours. Okay, so doing Anderson power poles, I have a video on that. It takes a little while to learn how to do all these things, but it's well worth it. You learn something and then you apply it to something else. Now, when you get the amplifier, when you turn it around, you'll unscrew the 2 screws there. One screw is smaller, the other screw is longer. And the modification is that when you create your proto board and with your components and solder it, which again takes a little while to figure that out and making sure it's well done. It's best to shrink wrap it. There are sharp edges to these. Try to clip them as best as you can, but sometimes even when you do the best job, it might poke out. So you can see that I have some vinyl tape on here, just in case none of the connections touch the aluminum plate. I'm pretty sure this is conductible. One thing that I did, which you don't have to do, but because I had a previous one and I didn't like the way I had to modify it, I got one of these strain relief tools. I learned something new. Here, this is a strain. Here, I'm gonna get a close up here. This is called a strain relief grommet, and it is it's pressured in there, and you can use this tool to pressure the grommet and then press it in there. Now what I did was I took it out, but you got to be very careful when you take this out because you don't want to tear any of the connections. That's very important. But I did that because I can't seem to operate in a very tiny confined space. So I pulled out the grommet, and then I was able to get access to the signaling line and also to the power. This way, I can easily operate on putting the correct wiring, the wiring, the keying wire to the proper place that is necessary, and then also tapping the power of the modification to the board. And so one thing that I recommend, if you're going to take out the strain relief grommet, you better put it back, because I was like, oh, I can't put it back, I don't know what's going on. Some people say you need to buy a new one if you take out the old one. And for a moment there, I was going to use just a tubing. I was just going to put a tubing, and that should be good enough. No, it's not. Because if you put a tubing here and this is not stiff, when you move these wires around, it's going to joggle this. It might joggle some other part, and it's going to come out loose. And then, I don't know, in about a few weeks from now, you're going to be like, what happened? Well, something got loose in there. So the strain relief holds things in place. But because it holds things in place, it's really harder to cut the line. It's not impossible. Cut the line and do other things in there. It's very feasible, but a little bit hairy. So that's something that I was able to do. So one thing that might happen, and this is something that happened to me, was that when you solder things, and this has happened to me many times, when you solder things, the soldering is really hot, and so the components might get damaged. So when you put these modifications, test it out before you start putting things together, because the transistor might have burned out. And if the transistor has burned out, and how would you know that? Well, because the keying line would be turned on all the time. You might have to replace that, or the diode burned out or something. It's really hard to know if the diode had burned out or not, but you can test it using your digital multimeter, and they can you can watch a video on how to test that. And actually, you can also test the transistor. You don't need a fancy tool. All you need is a, let's see, digital multimeter. And what you can do is you use the diode setting here. I'll put a video link down there, the one that I watched, and how to test that. It's important because if you put it all nicely together and you put the grommet, if you take it out and you turn it on and the signaling light, is it called the signaling light? If the transmission light is turned on all the time, you're like, oh no, something went wrong. And most likely something burned out. Okay. So the next thing that I want to do is I want to put this back together and then use a dummy load and a watt meter and see if I can get the wattage to go up, or the wattage to go up when I send out the signal. Okay, let's see if we can do that. Okay, so here's my setup for now. I have the MX-P50M, right, amplifier. It's turned off. I got the IC705, and I have this digital SWR watt meter from MFJ, MFJ849, and I have this dummy load that's for like 300 watts. So what I'm going to do is I'm going to transmit, but I'm not transmitting anywhere. So a couple of best practices. First, the amount of power that you want to use, don't use a lot. I was using sometimes 5. I might have been using 10 when I messed up my amplifier. So don't go very high. 2.5 or 25% should be good enough. You might pump it up a little bit more, but then you're going to start splattering. That's one thing. Another thing too, your mic gain you might have to change that a little bit. It all depends. I'm probably going to lower it down a little bit. I don't need it to be that high. Then also for your amplifier, one of the things that it does it in meters, not in frequency. And maybe while I was in the CW contest, I might have switched it in the wrong place because I was really excited that I was doing 17 meters or something. And I think I turned it into the wrong place. I transmit it, and that might have affected the amplifier. So, I put little tape here, painter's tape, and that's 7 megahertz, 10, 14, 18 megahertz, and so forth. Do you need to do that? No. Many people already know, like, 14 megahertz is 20 meter band. Don't you know? Yes, I do. But sometimes when you're excited and when you're, having some contacts, sometimes it doesn't work out that way. Okay, so I'm going to keep this focused here. Here's my microphone. Right now, everything's turned off. It's the information or the keying or my signal should go through. It's through the amplifier. So we're going to go over here. Let's see how much forward wattage at 2.5 watts. Whiskey Charlie 0 Oscar. Whiskey Charlie 0 Oscar. So you can see that there was about Whiskey Charlie. I was louder there. Looked like it gave me almost 3 watts. Hello, Whiskey Charlie 0 Oscar. All right, so what I'm going to do now is I'm going to turn this on. And you can see I have a blue light. This here is not turned on. If this is turned on while you're not keying, something's wrong. Then right here on this little light, I'm on 14 megahertz, so I'm good there. And I'm at 2.5 or 25% watts. And now let's see if it's coming out nicely or not. Okay, here we go. Whiskey Charlie 0 Oscar. Whiskey Charlie 0 Oscar. Whiskey Charlie. Whiskey Charlie 0 Oscar. Whiskey Charlie 0 Oscar. So you saw it's going to 10, 15. Whiskey Charlie 0 Oscar, 15 or so. And over here, as you can see, when I press the PTT button, Whiskey Charlie 0 Oscar, 1, 2, 3, and then release. Okay, let's try to see if we can hear ourselves through the SDR. I'm using the Kiwi SDR. Is anybody on this frequency? Is anybody on this frequency? Whiskey Charlie 0 Oscar. No, you see? And that's the problem. Right now, there's some blanket noise that just happened right now. Is anybody using this frequency? Is anybody using this frequency? Whiskey Charlie 0 Oscar. You can sort of hear me there, but can't. Turn on the amplifier. Give me a little more wattage. Is anybody using this frequency? Is anybody using this frequency? Whiskey Charlie 0 Oscar. And there you go. I'm right above the noise. And that is what I need for people to hear me for those particular days that are not that great. Is anybody on this frequency? Is anybody on this frequency? Whiskey Charlie 0 Oscar. And there it is. Not bad. Okay. And that just shows you that an amplifier can really make a difference in those really horrible days. Okay, have a great day, and I hope you enjoyed this. Please give it a thumbs up if you're still around. Consider please giving it a thumbs up and also subscribing. Okay, have a great day. This is Whiskey Charlie 0 Oscar. Bye-bye.